Okay, well, this is the last example that I'm going to do for section 3.2. And it says determine whether the pair of statements is logically equivalent. And so up here, I have added the definition to logically equivalent for you. There it is. Two statements are logically equivalent if they have the same variables, and when their truth tables are computed, the final columns in the tables are identical. Okay, we have two different statements. This is the, okay, that's this first statement. I'll just stick to yellow. There we go. And then here's the second statement. And you can see that they both have the part where it says two statements are logically equivalent if they have the same variables. Check. And when their truth tables are computed, the final columns in the tables are identical. Okay, so I have to do two separate truth tables. They both have P's and Q's, so P and Q. And your choices are true and true, true and false, false and true, false and false. And so for the yellow one, it's the negation of P or the negation of Q. And then the blue one is just the negation of Q or P. All right, so I'm just going to put a thing between them. Okay, so this one's our blue one, and this one's our yellow one, and this one has a pencil. Okay, so row, there's only going to be 4 rows, remember, because there's only 2 statements. And then I'm going to have a column for the negation, a column for P, a column for the or, and then the negation of Q gets its own column. And then over here, the negation of Q, the or, and the P. And I'm going to fill in, I have 2 columns that say P, so P would be true, true, false, false, and true, true, false, false. Okay, so sorry, none of this gets filled in. These are just, that's just messed up part there. Okay, so I'll do the yellow one first, and I will start inside the parentheses with this negation. That's going to be step 1. So when you negate Q, you just look over at Q. To get this column here, I'm going to look at true, false, and make that false, true, true. And then the second step that I will do is going to be the or, and that, to get this column, is going to be between P and the red negation of Q that I just did. And it's an or, so as long as one of them's a T, it'll be a T. But I do have 2 F's right here. So that'll be the only false in that column. The rest should be T's. Oops. And then the last thing that I will do on this is this negation right here. This will be step 3. And to get this negation, you're negating what was in the parentheses. So the last thing I did in the parentheses was the green column. So true, true, false, true becomes false, false, true, false. And I'm done with that one. And that one, the last column is this. That's the last step that I did. So when I go over to this blue one over here, step number 1 over here will be, I'll use a different color on this, how about purple, will be this negation here. This will be step 1 over here. And negating Q, all I have to do is look at Q, true, false, false. So that will be false, true, true. And then I will do the or in between. That's my second and final step. And on an or, again, there have to be at least one T, but right here I have two falses. False or false is false. So false or true is true. True or true is true. True or false is true. And so for this one, this is the final column. And so when it says up here, when their truth tables are computed, the final columns in the tables are identical. And when I look at this one, it's false, false, true, false. This one says true, true, false, true. They are not identical, so therefore no, they are not logically equivalent. And that's the end of section 3.2.